Well, thank you very much for inviting me to the event. It's the first time we're participating, and I really appreciate the opportunity to tell you about CloudPlugs. My name is Jimmy Garcia Meza. I'm a founder and CEO of the company. We're a software company that focuses on providing advanced edge-to-cloud infrastructure to help actually companies to optimize their operations infrastructure and to enable them to create new revenue streams. Our technology is very horizontal in nature. We serve multiple markets, but for today's presentation, we're going to focus on manufacturing. So as all of you know, there's a lot of pressure in a lot of companies in multiple sectors due to globalization, but in the manufacturing sector specifically, they're under a lot of pressure on their margins, and also the globalization has really complicated their supply chains. So for a lot of these companies, their immediate and long-term future is just going to be defined by their ability to adopt and implement cutting-edge technologies that enable the deployment of Industry 4.0. And everybody has been talking about Industry 4.0, but if we boil it down to what it means for the manufacturing industry, it's about implementing projects that help them improve their operations efficiency, reduce their costs, and enable them with new revenue streams. So the key for a lot of these companies is really to become agile through digital transformation and Industry 4.0 implementations. And what this means is that these companies basically need to have the ability to digitize and integrate their vertical and horizontal value chains, which means integrating their vertical processes inside the company and integrating the processes that they have with external parties, which is the horizontal value chain. So if they are able to achieve this, most analysts believe that this will help companies increase productivity about 18% over 5 years, reduce costs from 3 to 4%, which are important, especially for very large organizations. The second aspect of agility is the digitization and interconnection of their products and services. So here's where IoT has a predominant role, because IoT-based products can help them increase competitiveness. Connected products basically provide much better insights into the products themselves, as well as their operations, and can help them optimize them to increase revenues, a few percent per year. It depends on the type of company, but this could reach 10 to 15% per year, depending on the area that they're servicing. And the third aspect of digital transformation is, can these companies actually create new digital business models? And can they create them by having an integrated use and analysis of the data they're collecting from their connected devices and services? And then are they able to provide much better services through cooperation across their value chains? Because now that everything is connected, they actually have the ability to use that connectivity to implement new business models. So for example, many of the companies that we're talking to that have been traditional companies selling products as a one-time sale now are beginning to say, well, if I can connect my product, can I offer it as a service? One of the companies that's one of our partners, for example, has a very innovative robot to actually clean airplanes. It uses UV light, and it's a fantastic robot. You put it in the airplane, and it goes 7 minutes up and down the airplane, and it kills everything. It kills 99.99% of everything that's out there. So it's much better and cleaner than using, for example, chemicals to clean the airplane, which would take a long time. And it could start getting people sick if they're exposed to those chemicals all the time. So this company actually has this robot, and one of their business models is, okay, we'll sell the robot to the airlines. But another way they're looking at this is, now, should I offer the robot as a service, like as a cleaning crew? So the robot goes in and they charge per cleaning, as opposed to selling the robot, which provides a much lower friction to the airline industry, for example, right now, which is suffering economically, in a big way. So it's all about, using the technology to perhaps create new digital business models that are a win-win for everybody. So in particular, when we talk about manufacturing, we're going to talk about two aspects of manufacturing. One is the use of IoT and edge computing inside a manufacturing floor, and another one is the use of IoT and edge computing for connected products. So when we talk about the manufacturing floor, the use of these technologies is meant to do three things: improve responsiveness, reliability, and reduce costs. So how can it increase responsiveness? The fact that we can do edge computing provides much faster access to data locally in terms of ingestion and processing. It can be used to provide real-time insights for faster actions and much faster response to service requests, and to create an overall much better user experience. When we talk about reliability, we talk about having all the elements within the edge or within the plant itself, having all the processing elements there provides an environment that minimizes the chances of failure. The connectivity to the central office is no longer critical, so you don't have to be depending on the networks to provide, the responsiveness and connectivity. You can do everything locally, and then you can actually implement multiple edge endpoints to ensure immunity to not only failures, but also to potential attacks from external parties. And lastly, when we talk about reducing operation costs, doing edge computing with IoT means that there is no need for high-capacity cloud servers and high-volume data transfer capabilities. We have customers, for example, that are producing terabytes of data every month. So it becomes extremely impractical, actually, to be transferring all that data across the network, which ends up costing a lot of money every month. So having the capability of doing things locally reduces costs, not only in terms of bandwidth, but also in the cost of cloud servers, which are much more expensive than having a local gateway, for example. But of course, having the data at the headquarters, if these are remote plants, is important, but the technology is meant to be able to be structured in a way that only the key information is sent to headquarters and to the backend systems, while you keep all the important data and all the operational data locally in the power plant. So then we talk about smart machines. So how can we add IoT and edge computing capabilities to create a new generation of smart systems? So there are three reasons why we do this. One is to have much better visibility on the machine operations, having a digital twin of the machine which tells us what's happening with the machine at any one point and allows us to actually create scenarios that help us figure out how the machine may behave under certain conditions. And the third area is how can we have much better outcomes. So of course, having a connected machine gives us visibility, and having more data about the machine helps us make much better decisions as to what to do under certain conditions. In addition, adding artificial intelligence and machine learning on the edge also helps localize the insights, real-time actions, and much faster response to service requests. So being able to actually take the data, understand what the data means, and then taking an action based on that meaning is becoming more and more important for everyone, of course, because that helps you optimize your operations. Everybody has been talking about digital twins for many, many years, but it's not so easy, and you have to have the right technology to really build a digital twin. So what this is, it's a software object mirror of the machine. It contains all the event, state, historical reference data, all the data processing logic of the machine, And the whole idea of a digital twin is that you can have continuous intelligence of what's happening with the system through rules engines and optimization and prescriptive analytics. So analytics that basically let you understand when a particular pattern is happening or is going to happen based on data that you're receiving, so you can actually automate actions. And then the third area that's important for smart machines is, can we use the information of a connected system for better outcomes? Can we find hidden interdependencies, not only between elements or amongst elements inside the machine, but in the interaction of the machine with other machines on the network? And then having the ability then to recommend improvements, recalibrate the system automatically, do predictions of future behaviors and outcomes, and overall, delivering a much better product and user experience. So we've been working specifically in this area for some time now, and I'm going to show you at the end some examples of companies and how they're using IoT and edge computing to build their smart machines. So as CloudPlugs, we can help companies connect and optimize and add their units and add services very quickly. So we provide an optimized SaaS platform that can be deployed, offered as a SaaS service, as a dedicated SaaS service, or on-premise. Our platform is multi-tenant, and it's used to basically connect, manage, and provide real-time visibility on all asset operations. The platform can integrate with backend systems, analytics, and machine learning applications to help companies optimize their operations. And it provides all the tools to manage and deploy edge applications and container-based microservices on the edge to generate new revenues. So for example, you might have a system that has certain capabilities, and then you create a new microservice for that system that you can allow the customer to deploy and then charge extra for it, and therefore generate a new revenue stream for you. We also focus on short time to value. So out of the box, we provide connectors that cover about 90% of most edge connectivity and integration needs, whether it is to integrate a building, a machine, a telecom tower, a factory floor, etc. We provide out-of-the-box tools that can be used to quickly visualize operations data and gain real-time insights on the operations of the system or a whole plant. And we provide all the tools to easily onboard and manage an edge applications and services containers marketplace. So as you create your microservices, you can publish them and make them available to other people that are using the platform, and then you can offer them for free, or you can charge for them, eventually creating this opportunity of promoting your product and advanced applications across other people that are sharing the platform. So now let's get to the technology itself. So we provide really today the most advanced edge to cloud solution in the market. And on the edge side, we provide an intelligent, secure edge fog stack. So we can deploy our edge technology on the deep edge, which would be the machine or the manufacturing floor, but also on edge nodes that may be connected to the factory. So for example, we are working with Lumen Technologies, which is CenturyLink, which are, building 110 edge nodes across the U.S. And then our edge technology could be deployed on those edge nodes, to which then the customer machines or factories could connect, for example. So that would be the fog application, and the edge application would be when the technology is deployed on the customer premise. And then, of course, we have our intelligent secure cloud service, which is offered as SaaS or on-premise on any public cloud. So our edge stack is actually defined by 4 different technologies. So we have a technology that we call the PicoPlug. That is a very tiny agent that can be deployed on $2 microcontrollers to connect a microcontroller-based device to the platform. We have basically a stack of APIs that are packaged that can be deployed on custom boards. So if a customer, for example, if a company has a specific custom board for their HVAC system, they could use our libraries, deploy them on that custom board, and use those to connect to the platform. We did a project with an insurance company, for example, that has a baby car seat monitoring applications in which the baby car seat uses Bluetooth, and your mobile phone can be used to talk to the baby car seat and act as a gateway. So then we collect the information on the back end as to whether there is someone on the car seat. So if you forget the child, then you get an alert on your phone saying, you left your child in the car. Please go and deal with this. And if they ignore that, then this particular insurance company would call the police eventually, so that they could act, especially in the summer or winter, if a child stays in a car. So we have different technologies to connect all kinds of devices. And then, of course, we have the most advanced technology that can run on ARM x86 gateways or servers, which is called Edge 1. That is our advanced edge computing platform. So on the edge, basically, we provide the ability to connect with multiple devices and through multiple protocols, so we can integrate edge assets, ingest their data, and then we provide a number of tools for processing the data, analyzing the data, or creating automation on the edge such that you would be able to, based on a specific data or point or event, execute an automated action. Everything we do is open, so our Edge 1 platform is an open platform as well. So customers can build their custom edge services and deploy them and manage them themselves. So we provide also multi-cloud connectivity. So the edge data can be transported not only to the CloudPlugs IoT backend, but to Google IoT Core, Azure IoT Hub, AWS IoT, IBM, Watson IoT, or basically any cloud backend as well. So that's for the edge side. Then on the backend side, our intelligent secure cloud service is offered as a SaaS platform as well as for on-premise deployment. So if a customer wants to deploy this on their own, inside their own data center, they can do it. And what we do is we're a little different than most platforms out there in that we provide a fully integrated backend. So we have a near real-time multi-protocol message bus, really high performance on the periphery, on the front end of the back end. And we can ingest multiple protocols. And then we provide all the tools for device management. So you can onboard and enroll and then manage your devices. All the tools to manage the applications that run on the devices. We have a local database that allows you to store the data locally if you want to in our platform. We have a rules and geofencing engine to track mobile devices, and we provide all the security management end-to-end from the backend. We also have APIs that enable us to integrate with third-party applications for analytics, machine learning, or data lakes. So some of our customers, for example, are implementing data lakes with Cloudera or Hortonworks, and they want their data to flow directly to that infrastructure. So we allow them to do that through the APIs inside the platform. So these are the two core components that we offer. So we focused a lot on performance and integration. So talking about our Edge 1 platform, it's an open smart edge solution meant to connect and integrate any legacy as well as new assets and sensors. Edge 1 can run on a $40 Raspberry Pi, or it can run on a cluster of servers. We can ingest up to 100,000 messages per second on the edge. The platform can provide 360-degree real-time visibility into individual asset or an entire site performance and operation. It's used to also enable edge automation as well as new connection and compute services. So actually you can use Edge 1 as a compute engine on the edge. The platform is open and extensible, so users can create and deploy their custom edge applications and microservices based on Docker containers. And it can integrate with third-party operations technology as well as business systems, data lakes, advanced analytics, and machine learning applications. It's also cloud agnostic, so it can send data to any public cloud or IoT infrastructure. Our backend, which is called the CloudPlugs IoT service, provides near real-time data ingestion. It's a full event-driven architecture, so it's really high performance. And as we said earlier, it includes all the tools for device, application, data management, the rules, geolocation engines. It's a fully multi-tenant platform, so from a single instance, a service operator or a company can manage multiple other companies or divisions or factory floors within a company. Handles end-to-end security. It has a real-time analytics dashboard builder, which I'm going to show you here in a moment. And of course, we have the option to offer it as SaaS, dedicated SaaS, or on-premise with perpetual licenses. So our focus as a company is to help companies deliver better outcomes. So having better control and use of the remote assets to help them build these end-to-end digital supply chains that, as we said earlier, are important to integrate your horizontal and vertical value chains, and all this to drive more efficiency and productivity, have much better customer interactions, lower costs, and create new revenues. So it's a great platform to actually perform an Industry 4.0 and digital transformation strategy. So the customer segments we focus on are in the telecom sector, connected industry, Industry 4.0, so manufacturing, connected spaces for buildings, smart cities. And we did a lot of projects with connected energy and utilities. So we deployed the platform in several power plants, for example, for Enel in Italy, controlling different assets that were producing huge amounts of data. So for example, we connected some motors in a power plant that were producing about 4 gigabytes of data per hour. And we had the ability to ingest that data and pass it to an analytics engine for predictive maintenance applications. So the way this gets deployed, and this is a little bit busier slide that kind of shows the overall architecture on a deployment. So on the deep edge, we have the customer devices, which may be sensors, actuators, meters, PLCs, machines, or buildings. And then we have our edge service and management and delivery platform, which consists of the types of technologies we mentioned earlier. So if we want to connect a machine directly to the platform, we have our edge connection stack, where we have the PicoPlug agent, which is a 300 kilobyte agent written in C++ that runs on ESP8266 or ESP32 microcontrollers, which are very low-cost microcontrollers that are becoming more popular because people can use them actually to build low-cost boards under $10 and use those to connect to their device to the internet. We have SDKs in 9 different languages and 3 different protocols that people can use to deploy on their custom board. So for example, we have an HVAC customer that uses our SDKs to connect their HVAC units to the platform. We have the SmartPlug, which is a programmable agent written in Node.js, so people can build applications with JavaScript to connect their edge devices to the platform. And then, of course, we have the Edge 1 platform, which is a container-based platform that can also be deployed on a machine running Linux and use it for telemetry, control, data processing, automation, and mediation. Mediation means that we have also the ability, because we can speak multiple protocols on the edge, to allow 2 heterogeneous devices, completely different devices speaking different protocols to communicate with each other transparently. Then, of course, the other way to integrate edge devices is through gateways. So if a customer has, for example, an ARM or x86 gateway running Linux, they can install our Edge One, and then Edge One can actually perform the telemetry, so the data collection and sending the data to the platform, automation, protocol mediation, so enabling interaction between machines speaking locally different protocols, data processing. So basically, the platform is an edge computing infrastructure. It also supports local databases, so you can store the data locally if you want to for environments where you may not want to have the data flowing to the cloud, and you may want to keep all the data locally for performance or security reasons. You can run analytics. You can deploy your own machine learning applications, and of course, it provides multi-cloud connectivity. So we support a number of protocols to interface with sensors and PLCs, etc., including Modbus, all the flavors of Modbus, OPC UA, DA, Siemens Step 7, TwinCAT 2 and 3. We can interact with Pi servers, which are very popular in mining, and power plant applications, for example, with our Pi-J DVC connector. We have a flows engine, a rules engine, and we support 8 different databases locally, and we have a database visualizer engine as well, so people can visualize the data locally. And then, so this edge software, the edge software actually sends the data to our backend using MQTT or Kafka. And then on the backend, we provide with CloudPlugs IoT all the tools for device application, container management, the rules engine, the security database, the dashboard development tools, and the APIs. So then we can integrate with the customer's business and operation support systems, which may be a travel ticketing system, a workforce management system, an alarms management system, or the customer's data lake, which may implement a technology, as we mentioned, something like Cloudera or Hadoop, for example, for the data lake. And then they can have business analytics engines like Tableau running on it, or machine learning applications as well from Cloudera or other Pivotal or other companies. So this is basically what the overall architecture looks like. And the way this works is that we basically help companies create a software-defined asset and then build their digital services on top of that. So we look at the deep edge where the customer has their sensors, machines, etc. We call that the deep edge. And then in CloudPlugs IoT, the first thing we do is to try to define a digital twin for that machine. So we have what we call our production templates. And in these templates, actually, we define what are the characteristics of the device we're going to connect to. Then we would deploy, for example, Edge One next to the sensors, actuators, or in the devices itself, or on an edge compute service. And then we connect that Edge One to our platform. So we connect it to our device management system. So the Edge One actually gets some credentials. It enrolls securely using those credentials, and then it connects securely to the platform. So once we have the device connected to the platform, then we deploy the applications on that Edge One. So we deploy the connector modules. For example, if we're going to talk to a device speaking Modbus or OPC UA, we deploy the container on the Edge One with those protocols to enable the connectivity. Then the customer may deploy another container for data processing, and our message router to actually start sending the data to the platform. So you deploy this with one click into 1 or 1,000 locations. You start collecting the data, you can process the data, and then send the data to CloudPlugs IoT. Then what customers will do is they can use our tools to build this real-time analytics dashboard to look at KPIs so they can start visualizing the data. And then you have a pretty good view as to what's happening with your systems in the field. Now, what happens in a lot of the cases is that many customers will say, well, I'm using some machine learning or analytics tools from other services, like it could be Google, Azure, Amazon, or IBM, and then they want to send the data to those services as well, so they can ship that data directly from the edge to those, or from the backend platform to those. We can integrate with the customer BSS or OSS systems, the business operations systems, or send the data to a data lake. Then as time passes and customers start collecting a lot of data, they can run business analytics and then integrate their business analytics engines with the dashboard they originally built. And then eventually they can, as they have a lot of data, they can start building their machine learning models, or they can build their own custom application and service containers themselves, and then push those new services as Docker containers into the container management of the platform, from which then they get deployed on the edge. So now you have the virtuous circle, because we have completed a 360-degree operation on the edge, so where we connect the assets, ingest and process the data, send the data to the backend, and then use the machine learning or analytics models to perform automated actions on the edge to improve the operations efficiency. So this is how we close the loop, and this is how companies are looking, are deploying and looking at deploying this kind of technology. This is the way IoT and edge computing infrastructure has to be deployed to really build a full Industry 4.0 or digital transformation infrastructure using IoT. All right, so let me give you some examples of projects we've done. So we did a project for an integrated smart factory automation for a company that makes robots for car manufacturing. So in their particular case, their problem was that they needed to actually update the software on the robots to change the robot operation during the day, but those robots were not connected. And so what we did is we implemented a small control board using a very low-cost microcontroller, an ESP8266 microcontroller, using our PicoPlug agent that was talking to the serial port of the robot. And then we had our Edge One platform running on an Advantech gateway on site, providing the updates to the robot as the operations happen during the day or during the week, as often as they required. So all the firmware for the robot was deployed from the cloud into the Edge One, which would then update the software on the microcontroller board on the robot to change the behavior of the robot. So it's an interesting architecture where you have a multi-tier architecture on the edge. So we have the robot using the PicoPlug and the Edge One feeding the firmware to the PicoPlug, so the robot software gets updated, and then all the management on a web-based dashboard that would provide visibility as to whether the process worked properly or not, and how the robot was behaving at any one point. Another example is we work with the companies, one of the largest wood cutting machine manufacturers in the world. Their customers are companies like IKEA. These machines cost between $60,000 and $1.2 million. So what they wanted to do is they wanted to have more visibility into the machine's operations. So what they did is they integrate with every one of their machines an IoT gateway running our Edge One platform with our OPC UA connector. That is the protocol they use to extract data from the machine. And because we have an open platform, they build their own microservice applications and they package them as their own containers. And then they ship these machines all over the world, and they have a dashboard that their customers can use to monitor the operation of the machines. And they have their own dashboard, which enables them to, on a global basis, see how their machines are operating, so they can provide better service to their customers if there is a machine failure. And now they're working actually on the predictive side to be able to address issues before they happen, so they can provide a much better service and user experience to their customers. Another company we do work with is a company called EPTA. They're a company that manufactures refrigeration systems for both commercial and residential applications. Their customers are companies like Walmart and Carrefour in Europe. And they wanted to start connecting the refrigeration systems to basically be able to monitor them remotely and provide better service to their customers. In their particular case, again, they have a little control board in the units with an ESP8266. They use our PicoPlug agent there, and then a gateway that manages multiple refrigeration units in the supermarket, collects the data, processes the data, and sends it to the platform. And they have this dashboard that allows them to manage the machines remotely. And also they have an application that the operator from the supermarket can have locally to see if there's a problem with a particular refrigeration unit as well. So another customer is Clevet. They manufacture HVAC systems. In this particular case, they're using our libraries to embed them into their custom control board, into the HVAC systems, to provide visibility to their customers through a mobile app, as well as for them to have visibility across the systems they sell all over the world. These are both as well commercial and residential HVAC systems. And here's another company, Bonfiglioli. These guys make connected inverters, and these are high-frequency inverters for wind turbines, as well as for high-precision stone cutting machines. So there's a huge amount of data that we collect through them. In their case, for example, they needed connectivity to their own PLCs that use their own proprietary protocol called VBus. So what they did is they ported VBus, packaged it as a container, and deployed on the edge one. So we ingest a huge amount of data from these devices locally. And then, so we collect, temperature, torque, speed, energy, errors, hours of operation, set information. We process the data and send it to the backend. So, these are some examples. As I said earlier, we did several projects with power plants, with insurance companies. So we have quite a bit of experience. We've been in this industry for about almost 7 years now. So our technology is, very solid and robust. And so a lot of people choose CloudPlugs because we help them in a very easy and fast way to implement their digital transformation and Industry 4.0 implementations. It's used by enterprises, manufacturers, governments have a platform that can be used to build digital supply chains and services. The technology is very advanced. It's very well integrated to manage legacy and new generation devices and sensors. We help, of course, integrate internal and external business operations and support systems, as well as analytics. And a lot of our focus is to help companies transform raw data into information that will give them much better insight on their operations and fast actions when there are problems. People have the option to perform their analytics on the edge, their machine learning on the edge, and enable local trigger-based actions. And then, of course, create, deploy, manage, and update their edge applications and advanced human-machine interfaces or dashboards very easily. And, of course, automate all the processes to reduce costs and generate new revenues through digital services. So that's what we offer. So we have a great suite of customers, and we're interested in expanding our user base. And of course, if anyone here is interested, we'll be more than happy to follow up and see if we can do a POC, and you guys can do a test run of the platform. All right. Having said that, I would like to show you the platform. Do we want to take? Let me show you the platform, and then we will take any questions. All right. So let me show you. Actually, this application. So what I'm showing you right now is a real-time dashboard for a
Could you
manufacturing
to make sure we're seeing what you're seeing?
Okay. You are not okay. Very interesting. I thought it was going to automatically do it. I guess let me do it again. All right. Let me share the desktop and this one and share. Do you see now the screen? It's a black screen that says manufacturing. Okay. So this is a machine conditioning monitoring application for a manufacturing floor. So this is a live demo. So there are 3 machines connected, and for each machine, we in this particular case, we connected them with OPC UA, which is one of the protocols that's fairly standard in manufacturing these days. So for each machine, we're collecting a number of data points and then calculating the KPIs or performance indicators that basically show us the uptime of the machine since the production cycle started. So this machine starts production cycles at 8 in the morning East Coast time, and it has some planned downtime, each one of them. So you can see here, like machines 1 and 3 have started. Machine 2 did not start all their cycles yet, but you can see the uptime, downtime, faults of the machine, the scrap rate, which is how many defective units it produces, how many units it's going to produce during the production cycle, the number of units produced so far, time of production between units, the average production time. And then we measure things like the overall equipment efficiency, availability, performance, and quality of the production of each one of the machines. And then we calculate all that at a factory, at a plant level, so you can see basically what is happening at a plant level. Then you can go to each individual machine and look at different variables. So temperature, ambient temperature, vibration of the machine, torque, horsepower, rotation speed, voltage, current, energy consumption of the machine. You can just click on a specific variable and see the real-time data as it gets read from the machine. So here we're getting the vibration frequency. And when you're doing predictive analytics, you want to look at vibration, and you then take this vibration data, you calculate the fast Fourier transform of the data, and then you can come up with harmonics that may be problematic. And when you hit those harmonics, you may have a problem, and then you can call for a service of the machine, for example. So this is how people use frequency data, and then you can see the machine temperature. And again, you can see real-time and historical data. You can see any alarms from the machines and the value that created tripped a trigger. So here we have a trigger that when this vibration frequency exceeds 45, then we create an alarm, and the alarm, then you can set it up to be sent. You can set up your thresholds in this screen. For example, you can say if the machine temperature exceeds, here 45 for the frequency, you can send an email or an SMS alarm in addition to creating a visual alarm on the dashboard. So, for example, this is an application. Actually, we're deploying this with one of our partners that's offering this to multiple of their manufacturing customers, actually in the Midwest in the US. Here's another example of a different application. It's interesting, but this is a tower, telecom tower management solution. Looks like it just, this is also live. It's taking a second because it looks like that. So the towers are offline right now. These are 2 towers in Italy. One is a central office, one is a standard tower, one is in Rome, one is in Milan. But we can still see the historical data. So this sometimes they have. It's funny because it's a mobile operator, and sometimes their own mobile network goes down. So in this particular case, for this telecom tower, we have several sensors inside the tower for flood, smoke, door and presence, temperature and humidity. We're measuring the energy consumption inside the tower, the performance of the battery stations within the tower, and 2 HVAC units. And then, so you can go in then and see, for example, the specific sensors. And here, for example, you can see all the door events. So the last time the door was opened was yesterday. So somebody went to the tower to perform some operation. And here you see the presence. But what's funny is you see that the presence here, even though the door was opened yesterday, there was presence today. So we also have an IP camera that unfortunately I cannot show you there, but actually what we discovered is that there's rats inside this tower, and the rats are tripping the presence sensor. And they had no idea they had rats, and they were having some problems with some cables that were getting chewed up, and they use this technology actually, interestingly, to find out a problem that they didn't know they even had, which is pretty fun. And the problem is they still have the rats. Looks like this has been operating for a year as well. They can look at all the battery station data, the load current inside the batteries. You can look the rectifier current within the batteries, both real-time and historical data. The power stations, you can look at reactive power, whatever you want. And then the HVAC system data. So we integrated this whole tower. It took us about 2 weeks to do all this, and primarily because we had to spend quite a bit of time waiting for the people that have the HVAC units to give us the access to the unit and the variable as that we're supposed to read to come up with the to be able to display the data. Okay, so all these applications are built with our dashboard builder, and so you can do sophisticated applications like this, ranging from that to a home monitoring application if you wanted to. What sits behind all this, so these are the dashboards that get built, are two things. This is the IoT platform and our Edge One software in these examples. So this is what the IoT platform looks like. It's a web desktop. So you have a screen that allows you to manage your devices. So this is a demo account that we have with several devices. So we have some that are online and offline. So we have our R&D team in Europe, actually in Italy. So we have a lab there. And so this is some devices that are operating in that lab. So I'm here in Washington, DC. And if I want to see that device, I can just open it and I can see all this is kind of the digital twin of that device. I can see the system, operating system, network, CPU, disk memory of the unit. But this is really cool. So with one click, I can open a remote terminal on that device. So this is a full Unix Linux VT100 terminal. So I don't need a VPN to talk to the device remotely. I don't have to be spending on extra network and infrastructure. So I have that at the tip of my hands and directly from the platform. I can open a remote shell to monitor the application execution on that device. So this particular application is saying hello Gelmatic every 5 seconds. I can open a remote file manager, so I can upload and download files directly from the platform on the Edge device. And I can also manage the applications that run on that device. So here I have, for example, I have in my App Store these 3 applications, and this application called Gelmatic is currently running on that device. If I want to run a new application, I drag, drop, save, and that application will get deployed remotely on that device. So let me show you an application update in real time. So if you look at our little application store, you see that I have these 3 applications, and this application called Gelmatic.js is printing hello Gelmatic every 5,000 milliseconds. And if you remember this, we were, here, we're monitoring it's printing hello Gelmatic every 5 seconds. So let's update the application. I come to my application store and I'm gonna say, hello, Texas. I save and commit the application in the cloud. I deploy the application on the edge device. And now when I come here, this thing is bothering me here, okay. You see that I synchronize the device and now it's saying hello Texas. So, with a few clicks and almost instantaneously, I can go and update an application on an edge device, on an IoT device, or 1,000 of them very, very quickly. No other platform in the world has this kind of capabilities and these tools to do this, this remote monitoring today. You can do the same thing with application containers. So if I want to deploy, for example, an ActiveMQ broker on a machine, I can drag, drop, save, and I will deploy that container on that machine. If I want to deploy, for example, a PyJDVC connector, I just basically drag, drop, save, and then that container gets deployed as a microservice on the edge computing platform. And you can not only deploy them this way, but you can also remove them. So when you remove a component and you save, then that component will be removed from the edge device and the edge compute engine remotely. So we provide these really powerful tools for device management as well as remote application management. If a customer wants to build their application, they can build it with our script builder, or they can build it as a container, as a Docker container, and upload the application to our container management platform. And once it's in the platform, it becomes available for deployment on the edge. So a few other things. Then this is our dashboard builder. So for example, these applications that I showed you are built with the dashboard builder. And here you have, all the tools required to build this. You have a bunch of widgets. You can drag and drop them and build charts and do whatever you want. And you can have multiple screens in a single application, of course, and you can navigate through the screens. You can create basically headers, footers, or navigation bars, right, left, etc. If you want to update an application, for example, you say, I don't want the yellow chart, I want a red chart. You come on the platform, you select the widget, you update your widget, you save in the platform, and then you tell your user, okay, let's update the application, and then 30 seconds later you have a red chart. So we provide all these tools to really build applications extremely quickly and deploy them quickly and improve your operations in a very efficient way. So that's the backend platform. And then let me just show you very quickly the edge one. So the edge computing platform that we have has its own web interface as well, and provides you all the information about the local gateway or server operating the edge one. You have all the log information, event logs, logs for the kernel of the operating system, of the agent that's sitting under the edge one. You can run diagnostics. You can see all the operating system modules. You can do resets of the whole system or of the edge one from this interface. You can manage multiple users and all kinds of users that can connect to the platform. You can have all your settings for networking, for services, for the web service. One of the unique things about Edge One is that it has a built-in message broker. So you can use the internal broker and other custom brokers. So this is what enables us to ingest a huge amount of messages per second for processing on the edge. You can set up your network parameters, You can set up your wireless connections. Right now, this is a virtual machine, so there's no modem connected. So you have all the nice tools to set up the operation of the edge one. And then the way this platform works is, you deploy your modules. These are the microservices that can run on the edge one. So in this particular edge one, we have, a large number of protocols that we can use to build projects to connect devices. So based on those modules, then I can come in here and create my project. So here, for example, a single edge one is running Siemens Step 7 to talk to a Siemens Step 7 PLC, OPC UA to talk to OPC UA devices, Enocean to talk to wireless sensor networks using the Enocean protocol, talking to databases. So a single edge one can actually perform multiple tasks based on the containers and applications that have been deployed on it. And then it's very easy to configure. So if somebody wants to connect, for example, in a building, a new Modbus PLC, you basically create your project name. You select the protocol. So let's say it's RTU for Modbus. You set your serial port where the devices are connected, all these other parameters. You say next, then you connect your PLC. You say next, you create the registers that we're going to read. For example, we're going to read temperature, and you say next. And once you've configured your system, you say save and start, and we immediately start reading the data inside the edge platform. Then once the data is inside the edge platform, as we said in the earlier slide that was showing how this works, then you come in and you create a message router project. So, so you can then come in, for example, and say, I'm going to take the edge data, I'm going to send that data to a CloudPlugs. I can send it to AWS. I can send the data to Google. I can send it to IBM, or I can send it to a data lake. So then once you set up what is your destination, you can process the data with a filter function, and then you set up your routes, and you say, I'm going to take data from a specific project and from the Modbus project, and I'm going to send it to AWS. I'm going to take the data from Siemens, I'm going to send it to Azure. So it's an extremely flexible platform that enables you to ingest data, process data, and send data anywhere. So this is the engine that's behind, this side.
You were showing just now that you were configuring the edge one. It looked like you were locally configuring it. Can you also do that same edge one configuration that looks like it's local? Can you also remotely do that from the SaaS-based solution as well?
And not for the edge one, because you can deploy configuration remotely, but to use the user interface, you would need a VPN to the edge one to do that. Typically, what our customers do is they will use this to configure their systems once, and once they do it, they pretty much leave them, or they ship them to the field, and then if they have a VPN, they go and they can use this user interface, or they can use the platform to update the configuration remotely.
So earlier you showed that you had a terminal interface in. You said that was not via VPN. Was that done over the WebSocket connection to the Node.js server?
Which one? This interface?
When you showed the earlier when you were getting.
Oh, the other one. Yes. Yeah. So the other one is
on the edge.
Yeah. So what we do for the update of the agent applications, for example. So what we do for this one is we use actually a protocol called PlugNet that we invented that gives you the capability of actually doing this remote terminal and this JavaScript shell and this file manager. So when we did this remote update, we use PlugNet. When we do the updates for the Edge one, we use MQTT and PlugNet. We use both protocols.
And the reason I ask is due to the recent issues with SolarWinds, where they were having the remote client. I'm just very curious about your security infrastructure. And I don't know if everybody heard what happened with SolarWinds. It was kind of international news recently that basically their client got hacked, and they were having malware in their client that allowed people to infiltrate our government infrastructures. So, so one of the things I wanted to ask was what other. So, for instance, you have kind of a proprietary protocol to interface with the system, but what other security measures do you have in place to, lock down some of that?
Here are, for example, the types of permissions that you can set for inter-device interactions. So, for example, that tunnel that I showed you is it'll be pretty hard for people to hack into that tunnel connectivity to the Edge one where we have the remote terminal. But one of the things you can do is for each one of the devices, you can set up the level of operations. So the devices can only be read-only. Some of devices may have read and write permissions. Some devices, you can reset permissions to include devices that are paired with each other. So you have the capability from the remote platform as the devices are deployed to do two things. One, the device, when they get shipped and they connect in a specific mode, which may be read-only or read-write. And two, if you want to update those, you can do the update of that ACL remotely. Now, in the platform, if somebody was to gain access to the box that's running the Edge one on the edge, and so they hack to the Linux, if that depend on the type of permissions that you've set up on that Edge one remotely, they would only be able to access that particular device. They wouldn't be able to go and touch all the other devices coming back through the platform and talking to the other devices, because we manage those ACLs centrally. And the other security mechanism that you have is basically on the Edge one, we work with companies like Dell and Advantech and other ones, and we work with Ubuntu that they typically provide all the patches and security software to lock down the operating system. But with Dell, for example, they also have RSA modules that you can deploy on your edge gateways to improve the security and vulnerability of the system. So from the platform side, we manage everything that respects to the devices, but not the operating system security. And from the device perspective, then we have the ACLs that basically allow you to rule the type of interactions that you want to have among devices. And then if a device gets compromised, you can basically change the ACL here, and you can, you can do things like, for example, I can also disable a device temporarily, or I can delete the device completely from the platform backend. So there are several layers of protection that you have. So the basic level, you have the operating system and the ACLs, and then you can go and isolate the device temporarily, or you can delete the device permanently. But in all the tests we've done, typically if somebody is able to access one device, they may be able to access that one, but it's pretty difficult for them to go and create havoc and start touching all the other devices. From the backend side, we have a single access point to the backend, which is extremely protected. So we don't have multiple sockets, multiple entry points inside the platform. So we have a single load balancer, and that is extremely tightly protected. We host the SaaS version of the platform on the Google Compute Engine, and then if a customer wants to deploy it on AWS or Azure or IBM, they can do it, or they can deploy it on a VMware infrastructure inside their own data center.
So are the WebSockets dynamically set up, or are they a static WebSocket port number?
They are dynamically set up. And then, okay. No, sorry, okay. Yeah, so let me tell you something. For the WebSocket connections, only the dashboards use WebSockets. For the Edge 1 connections, those are MQTT connections and PlugNet connections for the agents. So the devices do not communicate to the platform using WebSockets. The devices communicate to the platform using MQTT and or PlugNet if they're using the SmartPlug, but only these dashboards use WebSockets to talk to the platform.
Go ahead, let's ask some questions.
So, can you hear me?
Yes.
Okay. So, how much of your business would you say is fixed, as in it's like at a site, like I even call like a cell site fixed, versus mobile, like fleet, maybe?
Yeah. So I would say 90% of, well, probably even more, probably close to 95% of the business is on fixed sites. And the main mobile customer we have is the insurance company with that they're using the mobile phones as gateways for the car seat applications. But most of them are fixed. But we do have the ability to track mobile devices. So let me just show you that part of the platform. So for example, let's take this data. By the way, so of course with the platform you can come in and set up all kinds of triggers. So we support threshold, location, state, bitmask level triggers and any data. So if you want to do a location-based trigger, you can come to an area, in the United States, and you can come in and, for example, create a polygon, and then you can create entering actions, and then you can say, let's create a custom action. When a device is entering, send an email, send an SMS, send a request to a server, publish data on another topic, so you can take an action based on the data received, or you can publish a trouble ticket in Jira, for example. So you can come in and set the SMS. So you build your triggers this way, your actions, and then you can have one polygon, circles. You can come and the circle, for example, and you do the same stuff, and you save your circle. You can add another circle, so you can actually calculate areas of overlap as well, and then you can program trigger actions based on location. So the platform has a geofencing engine, and so we can capture GPS data and use that GPS data basically to build the triggers and figure out where you are and execute an action based on your location. Other things you can do, you can see, everything about your device. So you can see how much data the device is producing, any quota you may have on the device, what amount of data is used by containers, the traffic of the device, how many emails it has sent in a month, or SMSs. So you have, a total view of the device operational statistics as well, from a single pane of glass on the back end of the platform. You can set up its location address as well, and and then, as we said, you can build your digital twin on the platform. On the security side, you can also see which dashboards are talking to this device. So here you have a number of dashboards that are connecting to a specific device. So the dashboards are what we call controllers. So if you want to delete a user, you can come in here and just delete the user from the and prevent access to that device from the central platform as well. So you have you have total control as to who's doing what with the device and the interaction between devices, because you could have a device that's a controller of another device. And here's where you can actually see what device is controlling another device. So here's the device, for example, and I could remove this device from controlling this particular device that I'm showing you. So that's what we have. So the platform could be used actually to track fleets of cars if you wanted to as well.
Jimmy, if you would, we're going to call it a stop for the moment, but those folks that are online, and Stanton and Bill, if you guys want to be a part of the after meeting roundtable, Gary has stepped into the other room there. You're welcome to go and ask more questions. We're going to close this down for right now so that we can adjourn here. But let me do a quick, Jimmy, thank you very much. We want to give you a fascinating presentation. And so Gary Ramsey is going to host the after meeting. If you can stay on for a few minutes, Jimmy, and answer any questions, and he'll facilitate any comments and other interaction then with you here in a few moments. We've recorded this presentation, so Chris will send me the link. I will add our sponsors to it and clean it up and send that link out next week. So if you're not on my email list or not a member of the IoT Texas meetup site, feel free to reach out to me, Ed Hightower on LinkedIn, or ed.hightower at IoT and Beyond, ed.hightower, IoTandBeyond.com, and I'll be glad to add you to the list and send you the link for this and to let you know about future meetings. The IoT Texas meetup site is a great place to go to look and see what events are coming up here for the North Texas, particularly the telecom corridor area meetings that we're going to have. Are there any other announcements, guys? Anything else we want to talk about? All right. If you have any speaker suggestions, let me know. Next month we will have IBM coming. Paige Krieger will be speaking and talking about IoT, edge processing, 5G, blockchain, and hybrid cloud. Many different technologies that IBM Research is working on. She's going to come and share with us how they can be applied for IoT going forward. And I need some sponsors. If you guys know anybody that would like to sponsor for $100 a month, that would help keep this going. I pay for the room and other expenses, whatnot, to keep this thing going. But hopefully we can continue this next year and continue to find ways for us to come together. So with that, I will close this meeting. And thanks for coming, guys. Hope to see you next month.
Thanks, Ed. I want to start off with Kay Shaw. Kay is one of the volunteers for the IoT breakfast. IoT.
Gary, can you hear me?
I can hear you.
Yeah, okay. I'm Kay Shaw. Probably know you if you're on the line. So, my company is Sales Enablement Strategies. And so what I do is help companies that have new technology find its fastest way to profitability. And I was co-working at the Addison Treehouse until Nancy Hung left, and she had introduced me to Mon Handam, who had built the wonderful facilities that we have there at Hexa. And so his goal and mission for Hexa is to give back to the community and try to provide startups with the tools they need for starting companies, which he did not have when he started his companies. But he is, I don't think I mentioned, he is a very successful entrepreneur. Could be retired and having fun, but now he's giving back to the community. And so there's multiple solutions that you have access to. The co-working facilities is one, and it's beautiful, and there's not any others like this from what I can tell in the world with the way it's laid out. And in addition to that, Hexa Global Ventures is there, and we usually have at least three VCs in-house about every day. They also have Tech Genies, along with some other companies, that as a member you get some of the resources at cost, and just kind of their margin markup. And if they do invest in you, they can exchange part of what you pay for equity. But if you haven't had a chance, you need to come by and meet everybody over there. I don't know what I would have done without COVID, during COVID, without having these wonderful people to support us, and very COVID conscious. And so thanks for the intro, Gary.
Yep. Thank you, Kay. David, do you want to go ahead and introduce yourself real quick and unmute?
Can you hear me okay?
Yes, we can.
All right. Well, David Bacon, M&A Technology, and we're local over in Carrollton near the Addison Airport. Always excited and glad to be part of the IoT breakfast. We really believe in what's being done and what Ed has done to connect everybody, and appreciate the opportunity. M&A, just real quick, we are a hardware integrator and manufacturer. So we do both hardware design and integration, and we do contract manufacturing. An example is we do have gateways like Jimmy referred to in some of their applications. You see the gateways. We do design, manufacturing, and integration of those types of devices. And as a matter of fact, we met Jimmy and got exposed to CloudPlugs, working kind of jointly on a project for the Girl Scouts of America. And Ericsson is involved in that, and Ericsson recommended CloudPlugs for that project and introduced us to CloudPlugs. So we're really excited to be a part of working, hopefully in the future, with Jimmy and his team on the hardware level. But we do have we've got a 40,000 square foot ISO 9001 2015 integration center in Carrollton. We have 3 data centers that we own. And so we're excited to be a part of the whole picture by providing the hardware piece of the puzzle.
Great. Thanks, David. Mark, do you want to unmute yourself and do a quick introduction?
Hi, this is Mark Siri. I'm the CEO of Team of Defenders, and we also have a spin-off company called Storage Defender. First, I just want to say hello to Ed Hightower. Ed, has been probably a year or two, and I'm just excited to be able to come this morning and see everybody. That wonderful presentation and just an awesome community. Ed, I remember when you started this, and I'm just very proud to see that this is going forward in North Texas, and what you said at the beginning just blew me away. Ed, awesome job for all of you guys that have been working on this. And so my company is a IoT platform and service delivery company. We are vertical. We go, very sort of, I would say, segment focused. We're focused on prop tech and commercial real estate applications. And in our space, we've done everything from sensors ourselves all the way up to the cloud applications. But very niche focused within very large segment of commercial real estate. So we're a prop tech IoT service delivery company. Thank you for the opportunity, guys.
Excellent. And we've got two Marks, a Mark with a C.
Oh, sorry, that was Mark Siri. You didn't say the end. That was Mark Siri that just spoke. I think I spoke over somebody else.
Yeah, no problem. We got two Marks. That'll happen.
Hi there, this is Mark Davini. I don't know if you guys can hear me all right.
Yes, we can hear you and see you.
All right.
Thanks for the video.
Okay, awesome. Just figured I'd share with the world here. So first of all, thank you, Ed. And Stanton, good to see you again. Been a while. So longtime telecom guy. I just helped sell long-range systems where I've been working there, just helping the transition now of the new owners and kind of looking what comes next. So looking to build an IoT service delivery platform. So intellectual property along with the services front end piece. So nice to see everybody, and thank you.
All right, fantastic. All right, John, you're next, and then we'll finish up with Shannon because she has a question, or because you got a question there. So let's go ahead, John.
Okay, can you hear me?
Yes, we can hear you.
Everybody has to say that. I'm John Hamer. I'm a center engineer with Verizon Business, and what I do is manage network expansion projects, mostly in the Los Angeles area. We're expanding the current network for all the 5G, Internet of Things, edge computing. It was really exciting to see the presentation today because that's a lot of things that my group is in the process of building the infrastructure out to support. I've known Ed for quite a while in some of our networking groups, so glad to be a part of this meeting. My main interests are Internet of Things and also anything blockchain and all the variety of platforms and projects that those blockchain environments support. So thanks very much.
Great, thank you. Shannon, we left you for last, and so we're going to let you launch right into our Q&A. So you've got an outstanding question, so we'll just have you introduce yourself and go ahead and ask Jimmy your question.
Okay, I will. So my name is Shannon Duvendak, and I actually had a 25-year career at Caterpillar and really worked across all of the different verticals in that time frame. From, my background is technical, undergraduate, graduate degree in computer science, worked in the supply chain, worked in IT, worked in manufacturing, and the last part of my job is my favorite because it really took the OT and the IT together, in which I was leading the product development of putting IoT on our engines worldwide and collecting all that data back. And as you know, I'm sure a lot of you guys are familiar with IoT, but no unplanned downtime, the normal use cases that you would have monitoring all the different parameters coming off the engines from small to very, very large. I am now working as a partner in a company called IoT Launch, and it is our mission is to help all these companies who start to do IoT POCs and just can't seem to get out of the POC to bring the ecosystem together that would help them actually launch and get their projects scaled. So that's what I do. And my question is, how has COVID, I'm doing a little bit of research because I have to speak at CES in January, but how has COVID changed businesses, and specifically, how have they used IoT to help them deal with this crisis? When everybody went home, has anybody seen any type of use cases that have really helped businesses with their continuity? Besides Zoom, right? It goes beyond Zoom.
Yeah, sure. Thanks for the question. Well, let me tell you, I think COVID has had a really negative impact in a lot of the businesses we've been working with, because a lot of these manufacturing companies had to shut down operations, reduce operations. So a lot of the projects, several large projects that we had actually have been delayed until next year, and there is not a real timeline. So for us, it's been pretty tough year, I must say, from the IoT perspective. Some of our customers, which were in production, have continued their production, and they haven't slowed down because they were just ramping up and their volumes were not near the height that they were predicting. So that business has continued. But for a lot of our other manufacturing customers, they really slowed down their production, and they really slowed down their IoT deployments this year. So many of our projects got pushed to next year. And so we're hoping that next year is going to be a great year, but this year in particular has been tough. From what companies are doing, it's really interesting because a group that we were working with at Air Canada actually is the group that created, and you can check this really cool video. It's called Aerohygienics, AEROHYGNEX, I think. And you can see it on YouTube, and it's this robot that was talking at the beginning to kill COVID inside airplanes. So that's an interesting project that it's a COVID-related project that we started working on this year. It's pretty exciting. We connected the robot to the platform. They were very excited because they did it in just a few hours from beginning to end, and now they have the ability to monitor the robot remotely, and they're looking at this business model of actually offering the robot as a service. But so that's kind of been an exception. Everybody else has really slowed down in their projects, deployments, and the POCs going to production. A lot of them are looking at Q1, hopefully, as the starting point to start moving some of those POCs to production. So we'll see.
Is everybody else seeing that same type of response, and the IoT is slowing down, or has it sped up in some cases? Mark? Hey, Mark, we can't hear you. Are you muted?
Good. How's that? Does that work?
Yes.
So I do recognize what the other gentleman had mentioned. On our side, what I've noticed and how we're engaged is wherever you have point of sale, wherever you have person to person, and where there's currency exchange, in other words, sales, what COVID hindered, IoT has provided the promise for automation and cashless automation from in whatever particular business segment we're talking about, where you had human interaction before, and you can automate with that IoT component, automate leasing, automating contracts, automating cash exchange, automating access entry. Anything you can do in that chain to get a prospective customer to endpoint, and some of them are very narrow applications, and some of them are quite broad. The idea of cashless point of sale has been big for us in IoT is germane to that. So we've actually seen a surge.
Yeah, that's very interesting actually, because I think from a manufacturing perspective, I think which are and our telecom customers, we've seen that slow down a bit on that side, and we're really expecting some of the, for example, tower management projects to go faster, but no, they have all really slowed down. But it's great to hear that there's some areas where obviously IoT has a tremendous value and opportunity to add value in situations like this. So
yeah, it's a different, I mean, there's a favorable way of looking at it, then there's probably perhaps a less favorable way of looking at it, right? But for applications that were built on, hey, we'll take the very nature of that particular production facility, if it itself is running in lower production because of less demand, obviously the idea of putting investment into an area to help operational might not be their focus right now from a financial perspective. It's preservation. So if you look at moving over to what's really creating sustainability, we get a lot of questions about what's your own company's sustainability plan, but more importantly, how is your solution going to help a company sustain during this pandemic. And literally, we're an early stage venture, so we talk to a lot of investors. One of the requests I started getting as a firm was, what is your crisis and COVID sustainability plan? How do you sustain? So now if you flip around and you talk to companies, what companies are struggling because of COVID? And the thought-provoking question becomes then, how can IoT help that company sustain? That becomes a new value proposition. And so obviously, since it's person to person, people are getting sick. If even in a production facility, if people can't go to work and production unnecessarily drops, if there are solutions that can unfortunately automate, lessen the load, the number of people, or replace people, unfortunately, those I believe are getting, those are the class of applications I believe are getting a surge in demand from at least what my counterparts are telling me.
That's good to hear, because I'm hearing the same thing. I actually heard that COVID has pushed IoT, or actually technology and the digital transformation, a decade or more forward, because there are definitely some companies that are being aggressive. I know, Kat, where I worked at, I know there was a lot of budget that was going towards it. So opportunity.
How's the session work? Are we supposed to come in and ask questions like that? I'm new to this, so I don't know what's normal. Am I supposed to respond?
Absolutely, absolutely. Now, this is, this is in substitution of you guys actually showing up here at the building. Obviously, you weren't able to make it for some reason, but we just want to be able to create that interactive environment that you would normally have if you were here in the building with us. So this is exactly what this is all about. It's to kind of extend the interaction between everyone, exchange telephone numbers, contact information, the whole bit. Obviously the whole reason that we network is to help each other, locate, find, and close business, and extend the ecosystem, as Ed was saying earlier. So I
have a general question I'd like to ask the group, because I've been out of this I know Ed from probably 2 or 3 years ago, so I've been out of this sort of forum, but if I might.
Absolutely.
So I hear a lot of comments about build POC, build POC, build POC. And couple of years back when I got into IoT, I was pretty early in. It was like, oh, is IoT real? It's just a bunch of fluff. And then it was, you need to know your use case. And then there was, hey, let's build POCs. And I feel like there was this surge to build bunches of POCs, but it wasn't exactly, what are they for? What's the return on investment? Like, was the value the POC, or was the value the business plan around it, right? And anyways, the soft question I have, and I'd just love to hear people's thoughts on it, is, is there too much focus on POCs and, kind of chest pumping, hey, we can build POCs? And two parts of it. Are the platforms really gated by only being able to deliver POCs versus enterprise-grade solutions? Part one. Part two, are companies sort of feeling entitled to get POCs, and they kind of stop there, and it's kind of like the startup world where 99 out of 100 POCs never go anywhere. Like, I'm kind of looking to get a pulse on the importance of doing POCs, and have we tried to build the truth there? But it's kind of it's a half-hearted attempt to try to get business, because the real work hasn't been sort of built to build a whole business plan before you built the POC. I don't know if I'm asking it right, but I would just like to hear anybody comment on POCs and how prevalent they are, and are they helpful, or in some cases, are they a detriment?
I'll just jump in and give you my 2 cents on that. I spent about 2 years with Avnet. Avnet had the capability of pretty much A to Z when it came to IoT. The only really missing piece for them was they weren't a telco company, but they could effectively build a board, put firmware on it, and find some way to backhaul the data from that particular sensor or device, get it into the cloud, monetize that data somehow with dashboards and augmented reality, virtual reality, machine learning, AI, connecting it to the enterprise, the whole bit. So it kind of gave us an opportunity to see lots of different proof of concepts coming through, proof of, PO XYZ, right? So you're right in the aspect of, a lot of proof of concepts are out there, they're developed. Typically, in our case, we saw a lot of stuff coming from Microsoft, which was one of our largest partners. In fact, it was probably more business coming in from Microsoft than actually the Avnet sales team of 700 people, but that's a whole other story. But effectively, we would have the opportunity of, companies like Starbucks, for example. They had a use case where they wanted to reduce the amount of time that it took to jump from location to location to actually clean out the coffee machines. So there was a large ROI that they could build around that they could do that on paper. But then the question is, how do we build that, right? So we would take a Raspberry Pi and we would do, a proof of concept, get it to talk to the internet, suck some data off the device using sensors and so forth. And quite frankly, most of those projects, whether it was, I can just list a ton of companies that are Fortune 500 that will bring us stuff like that, whether it's Walmart or Home Depot or whoever, that quite frankly, you're right. A lot of those don't always go all the way to the end, for the major product or project. True Green was another example, in the fact that how do you prove out that the technician is actually spreading out that fertilizer or chemicals or so forth on the lawn? So we were using IoT to actually follow one foot step and so forth. So they knew exactly how the chemicals were being applied and where they were being applied, so that the biggest issue they had was turnover, because people would go, I don't know if I'm getting my money's worth, and they could go back and they could show them the plots of the chemical distribution and the whole bit. There was a lot of money spent on the proof of concept and various different pieces of that. But the one thing that a proof of concept does do is it allows you to see whether the idea that you have, if there's an ROI behind it, build it to a certain point. You don't have to have every dial and graph and all the back end analytics just to prove whether you think you can get the ROI or not. Now, I think your question might have been more of, do I just build proof of concepts for the heck of it? I don't necessarily agree with that, because there's so many applications for IoT. You have to be a genius to be able to hit on what something that you can specifically monetize.
Let me narrow the question down, because you've covered it. You've hit to the point. And what I have noticed, or really a question again for you and the group, is this effort's put into the POC. You prove it can do X, Y, Z, but is the hard work thought through of, okay, if the POC gets done and it proves that, to actually meld that into a production system, this is what it really means in terms of the investment. This is what it really means to deploy an enterprise grade network. This is really what your support staff is going to need. Like, in the POC, is it just like, hey, we can do this, but the true investment and the time to develop that into a True Green or to a Starbucks solution is, I'm just making this up, some months or years and some millions of dollars of investment. And so what looks like a good POC gets shot down when the real work is done on the enterprise grade solution. I'm just wondering, there's a lot of platforms that look like they can go from POC to production, and perhaps, and that's the gold, right? But how many POCs are brought to the ROI where, again, and maybe that's what you're doing, Shannon, when you guys are looking at your deployments, where it just stops there because they haven't thought of what it really means, because, oh, it's cute, it works, it gives you a good ROI, but really does it?
Right. And so I think that the idea of doing a POC is a good idea. to go out there, do things like design thinking, test that out, make sure you're building the right product for your customers, and make sure it's solving a problem they want to pay for, right? But there's a lot of times they haven't thought through all that, having gone through the whole product development lifecycle. I mean, Caterpillar's been putting out telematics devices for decades. They have millions of devices out there worldwide, and it takes a lot, right, to be able to do that. But they are starting to reap the benefit of that, especially in this world of COVID, when you can't really necessarily send an engineer out into the field, and that they can remote monitor and see what's going on, get that digital thread, getting the digital twin to be able to do that. I think a lot of companies that do it, they didn't have, you need to have support, and you need to be able to make that investment. And there's a lot of it, you know, between the security that you have to put in place and make sure you're doing attack and pen tests to make sure it truly is secure. And that's an ongoing thing, by the way. It's not a one and done. To being able to, you know, get the hardware piece out there, have a distribution, you know, integrated into your supply chain onto the manufacturing floor, right? You have to put it into your product, you phase in, you phase out, all of that. And then to, you know, be able to support it out in the field. You know, it's a complicated, IoT is complicated, and I'm not sure everybody really appreciates the complexity in there, but it can be done. You just need to have the right partners in the ecosystem, which I think a lot of you guys are part of, right? So it can be done.
Yeah, and I agree 100% with what
Yeah,
you
so
said.
Mark, I guess I'm just kind of react a little bit to what you were saying, because I think kind of Shannon looked at it from the other side. So there's the product management and development side, right? And then there's the sales side, right? And what I found on the sales side, it depends who you're talking to. Because if you're high enough level with the guy who can really spend the money, he's not telling you how to do it. But you get down to the level of the person who knows how it's supposed to work and can evaluate the technology pieces that, you know, performance and capabilities and things like that. They love that stuff. They like to tinker. They like the POCs because they want to kick tires. They're not looking necessarily at least immediately looking at how to solve the business problem. So they're not ready to cut a check. In fact, I would say they don't have the budget to cut the check. So you spend a lot of time proving to those people that you can do what you say you can do. So that's my take on what goes on.
Yeah, I'll jump in and tell you, we had a program at Avnet that we called 333. It was 3 days, 3 weeks, 3 months. And we started off with a 3-day workshop where we sat down with the management team and we worked through what is the business problem, what is the business issue, and we charged them like $5,000 to $10,000 for the workshop. Now, when you charge them for a workshop, they're interested. They got skin in the game. They want to tell you and bleed all over you and tell you what the issues and problems are. That was really key for us because we would do the workshops and nobody would show up for free. I mean, obviously, it's a front-end sales process. Did we need $5,000 or $10,000 at Avnet? You know, that's a rounding error, right? So it wasn't a big deal there, but it was to try to get those people in a room. And we got the right people in the room. And when that happened, you know, utilizing some of the techniques that we had and methodologies and so forth, we were able to extract from them a list, and in some cases up to 20 business issues that they had. Then we would do the magic quadrant, like what you see with Gartner, and try to figure out what's the easiest project we can do, and then what's the cheapest project or least amount of cost. And we would rank all those, and we would let everyone in the room vote on what particular project was important to them. And by the time we were done, we had a nice big list of issues, problems, the whole bit, and buy-in from the team. So we took that and we would go build that prototype. So you've got to get that front end buy off before you go in necessarily with the POC, because again, that workshop allowed us to determine some of the ROI and determine what is actually a project that's going to have success and which ones are going to be the long-term, very expensive. Let's stay away from that, but let's get some buy off in the organization. Let's get some wins. And once that happened, you know, the spigot turned on, because if you're starting to show, you know, high ROI on these projects, you know, the checkbook comes out and they start to see and realize the whole advantage. And again, it really has a lot to do with the ecosystem that you're building around you, because
and it makes sense to me what you guys are saying. Like, I'm coming in fresh with, I'm more of a product. I'm more of a solution. I take products and solutions to market. So my view is there's sort of a consultative sale where you come in and say, we have all these, let's understand your 20 problems, like you said, and then we'll build a POC. That's one way. Way I look at it is when you went to Starbucks and you solved that problem, you now gain knowledge that equivalent enterprises with those same equivalent problems then have. You then put a box around that and you can go to them and say, I have this, I can't even make up a name on the fly, this coffee connoisseur IoT solution, right? You make up a name for it and it's going to deliver these specific benefits. And it's marketed, it's got a nice polish around it. Now, obviously it has versatility to do other things, but it's not a POC. It's an actual product that has demonstrated benefits that are defendable, clear, evident. You know, it's like buying an Amazon Alexa. You kind of know what to, you know, it's versatile. You know what to expect to get it. Can these solutions, instead of being sort of positioned as we can do whatever you need, let's understand your 20 problems, can we go into enterprise and say, here's the problems we at least know we're going to solve, and this is the exact product to do it, and then let's have some other discussions once we get in.
Yeah, and I agree 100% with what you're saying. And fortunately, you know, Avnet with 128 on the Fortune 500 list, they had a big marketing machine behind them. We would do a solution like what you just discussed, and then we'd stick that in our booth at a CES or a Global Petroleum Show or whatever that happened to be. You know, we spent, you know, $100,000 to have a nice big booth and, you know, blah, blah, blah. So you're absolutely correct, because people would come by and they'd see the coffee machine and they go, oh, what are you doing with that? You know, whatever. So again, we're not all Fortune 500 companies with big, massive booths at shows and so forth, but the concept's the same, right? It's just a matter of how you're extending that marketing budget to utilize the projects you've already done. I mean, that's really the problem that you have, even as a large company. You know, what areas do we spend our money on? What applications are we going to write? Because, you know, the world is our oyster. With an IoT platform, you can do just about anything you want with sensors and, you know, actuate. Just, you know, I'm kind of preaching to the choir here a bit, but my point is, it's very difficult to really pick what is that killer app going to be in 2021, so I can have that POC ready and I can start showing customers and start marketing that particular you know, product or project. As I said, Avnet was able to create our own products from scratch and go all the way to the other end and deliver those Fortune 500 enterprise level solutions. So a little bit different animal, but that's what this whole IoT breakfast, IoT special interest group's about, is to kind of help the little guy, right? Not necessarily the Fortune 500 companies, to build out our ecosystems. Because what you'll find is the ugly truth in our industry is 60% of our projects fail. And it's because we don't have all the puzzle pieces that are required to make this happen. So again, my 2 cents. I didn't want to dominate the conversation. Jim, do you want to say anything from Jimmy, from your perspective?
I think everyone, you know, is looking for this thing that you can do, and then it's a cookie cutter. You repeat it 100 times. Beautiful, right?
Yeah.
Unfortunately, that hasn't been our experience. I mean, I can tell you, I can go to a wood cutting machine like the one I showed you. SCM is one of the top companies in the world, an Italian company. I can go to the exact same competitor of that company, and they will have a completely different view, a completely different type of way they want to interact with the machine, and you have to start all over. It's been quite difficult, actually. Sometimes I look at it, having a horizontal platform is a good thing because you can apply it to multiple things. But on the other hand, it gets very difficult to have, you know, these cookie cutter models. Sometimes guys like the guy from Samsara, for example, that was, I guess, in the call earlier, I don't know if he's still here. they have a focused solution for vehicles, and that's what they do, and they did a fantastic job. The company's awesome. And sometimes I wonder if it's not better just to focus on a really narrow space and just do that. Because I can tell you, if I had been lucky to sell to Caterpillar, whatever projects I did at Caterpillar, I could probably not do the exact same project somewhere else. It's just, what we find is that every company that we talk to, at least in the industrial sector, has their own particulars, and they want to do things in a certain way, and you either do it that way or you don't get the deal. From a POC perspective, so we've gotten smarter over the years. So we only do POCs if we know that the project will have budget behind it, and if the right people are involved, not just the technical people, but the business people, the marketing people. Especially when we're talking about a product, you want the product people to be involved in the decision from the beginning and be part of the process, because otherwise you could find yourself with a great technical solution that nobody wants to put out in the market, right? And so we tend to be very careful. We charge for every POC, because otherwise, you can be wasting your time. But even then, we try to be very picky as to how we do the POCs, because you can spend time, you'll make some money, but in the end, if it doesn't go to production and you don't sell thousands of licenses, then it's not worth it, right? So in our business, for example, if I don't have projects where I can connect hundreds of devices or thousands of devices, it's just not worth it. So we need to be very careful from the onset as to how the POC gets conducted and who's going to actually finance the deployment. And if that's not clear, we try not to do it. We try not. We'll tell them go call someone else. It's tough.
Hey guys.
Yeah.
Oh, sorry. I was going to say, I just wanted to say thank you very much for letting me attend. I don't know if you guys did this before COVID, where you'd have it online in the online events. I'm in Peoria, Illinois. It's really hard to get down to Texas. So having this available has been a great treat, and it's been wonderful meeting all of you. And hopefully, like I said, you guys continue this, because I'd like to go to future ones. Thank you. I have to go to another meeting.
Yeah, we're glad you were able.
Bye, guys.
As well. Thanks, guys.
Thank you. Anybody have any additional questions at this point, or should we go ahead and conclude?
Gary, are you still at Avnet?
No, I'm not. I've gotten involved. I'm a serial entrepreneur, and quite frankly, that's just where my calling is. So I've joined a buddy of mine, and we've created a company called GT Ventures, or Growth Technology Ventures, and what we're actually doing is bringing companies that are offshore, Taiwan, Europe, a couple of other locations, but effectively we're bringing their technologies into the U.S. With U.S. representation.
Do you, if I were to share with you, so I have a ton of experience over there. I used to run Smart Home for Philips Corporation, and when we started a couple of years ago, and I had done semis before that, so I have a lot of experience in Asia. We're pretty focused in where we go with like a certain set of products that we've developed, but I always, I'm hard pressed. We have other products that we don't want to develop, but we want to bring into our network, and I know they're sitting in Asia somewhere. Is that something that you would specialize in, or do you only represent certain categories, or do you specialize? Like if I told you I'm looking for a certain type of, Bluetooth or wireless access, building access specific devices, would you have a network that you could tap into to help us and provide value that way?
Yeah, I mean, I hate to say it, but I can always default back to Avnet, which claims they pretty much have everything. But outside of that, I just as soon actually source at the original source itself. Just as an example, Georgian Technologies, which is a company that we're representing here in the U.S., they have, let's call it Google glasses. I want people to start saying Georgian glasses, take that away from Google. But effectively, the CEO has claimed that he's going to have that down at an MSRP at $500. And companies like Microsoft have been knocking on his door saying, hey, we'd like to kind of put our name on that and go to market, because the HoloLens, which originally came out for $5,000, just can't compete with something that's at that particular level. And in my experience with the HoloLens, a great, hey, I don't know exactly where to go with this, but effectively, I was at an Air Force base in Macon, Georgia, Warner Robins, and I just happened to run into the C5 crew that were effectively responsible for tearing that thing apart all the way down to nuts and bolts. They know everything about the aircraft. And we were already working with their facility, and the fact that the factory manager, they refurbish parts for the C-130s, all the cargo planes there, and rebuild those, because they can't get those parts now because some of those airframes are 60 years old now. But effectively, they wanted to be able to walk up to a device, high valued asset within that factory, and inquire using virtual reality, augmented reality, so forth and so on, IoT data. So what's the amperage in this unit? What is the, any open work orders, so forth and so on. So we were going to provide, we provided a solution for them for less than $100,000. That included the
Jonathan Reeves. By any chance, Jonathan Reeves?
No, I don't.
You said were you the guy that was in Siena? No, that was a different group. I'm sorry to cut you off, but there's a guy that's doing something very similar to this. His name, you can look him on LinkedIn, Jonathan Reeves, Reeves. He used to work at Mangrove. If you check them out, they're very similar sounding to what you're doing with augmented reality. It's very similar.
Interesting. I've got Bill sitting right next to me, and he goes, "I know him."
I knew Bill would know him. If Bill's sitting there, I knew he would know him, because if you can see in Siena, he was at Grove. I was in Telco as well. So Jonathan Reeves, you should look him up if that's what you guys are doing. Hey, I've got to get going myself. Gary, what I wanted to say to you is, you probably know Emilio, and you probably know Lou Lutentensky. I can't pronounce his last name.
I do know Lou.
Yeah,
I can't pronounce it either. But I worked with him for 2 years.
I had reached out to them maybe a year ago. I was in the search for exactly what you're doing, and my only challenge with going with the Avnet platform was it's all Microsoft based, and I didn't want to be linked into having to do a Microsoft based solution.
Yep, and I was part of SoftWeb Solutions before it was acquired by Avnet, and that was our platform. So I'm very familiar with the software.
Love to catch you offline, and again, really appreciate this venue, guys. I'm going to definitely be attending these. This is I learned a lot just listening from the presentation, but also just the discussion here. So really appreciate it, guys.
I'm going to go ahead and put my contact information down here at the bottom so you can reach out. Okay?
Yep. And Mark, look forward to catching up with you hopefully as well.
Yep. Take care, Mark.
Yep.
Okay, guys. Shutting it down. Thank you.